example, we're going to analyze the equivalent of, or the equivalence of a transistor in AC using a T model. Then we will convert it into a pi model. So let's say we have a transistor where we have a base, collector, and emitter, and this happens to be an NPN transistor. So how is this structured, mechanically speaking? So if we have all the semiconductor junctions to represent this transistor, it would be something like this. So, and where the base is connected to P, so this would be the base, this would be the collector, and here will be the emitter. So what we have is a junction right here that we need to break. So it's a forward junction where typically we'll end up, for this transistor to work, we need at least 0.7 to 0.6 volt in DC for this transistor to operate. But because of that, that means there is some resistance at this stage. So can we model this with that resistance in place? And the answer is absolutely. So here's our base here. And I'll model the collector side in a minute. So let's say we go this way, and let's call this one, and this is the emitter, little RE prime, okay? So the prime notation, we will see that again later on. So right now, let's just call it a resistance. So we have some sort of an impedance between the base and the emitter due to the forward junction here. What else we know about transistors? If we do achieve this voltage here, that means now the transistor is biased properly, and we should have a current IC. Let's do it in lowercase, since we are dealing with AC signals. And that IC is, think of it as a current generator. So let's go ahead and do that. Okay, so here's our IC as a current generator, and here is our collector. Now, that current generator, IC, is still related to the current IB going through. Okay, and remember, we also have a current IE coming out. Now, assuming all of this is connected, the only way you're going to get any of this if the circuit is already connected. Okay, so we're assuming this is already connected. We're just looking at the AC equivalency for this circuit. If that's the case, then we would be interested in a few things. What is the total or the impedance seen from this stage? Right? So what is Zn seen this way? Okay, so let's think about this for a minute. Let's say we have IE going through RE. Well, that means we have a voltage from here to here. Now this time I'm going to write it little VBE in AC. So we have a voltage drop there. Okay, we can conclude that Zn, applying Ohm's law, right, will be equal to VBE divided by the current coming in seen from here. Here's my I right here, and I'm looking at it, and I'm looking at a current going into the system. Okay, so I am basing it on that current as my reference, so I'll put IB here. Okay, what else can we say? Well, what is this VBE in AC? Well, that's IE RE prime, and then the whole thing divided by IB. Okay, well, what is IE? Well, IE, we have a current node here, which means it's the sum of little IC plus little IB, okay, everything times RE prime, everything divided by IB. Okay, now there is a relationship between IC and IB, and that is typically equal to beta IB. Okay, so beta being the forward current gain. So Zn is going to be equal to beta IB plus IB, everything times little RE prime divided by IB. Let's factor out IB, and that would be beta plus 1 times RE prime divided by IB. Can we simplify this by removing IB from the numerator and denominator? Absolutely. So Zn will be equal to beta plus 1 times RE prime. Okay. Can we also say, since beta is going to be at a much larger order than 1, that Zn is approximately equal to beta RE prime? Answer is absolutely. So if this model leads to something like this, can we reconfigure this model into something else? This is here going to be called the T model. The T model, as you can see, we have a T junction. So we have this line here and then this line here. Okay. What we want is a pi model. A pi model would look like this. Remember, you will still need the same impedance. So from the base, as far as it's concerned, we have that impedance, okay? And here's what's going to happen. We're going to have the emitter right here, and we still have the current going this way, and here's the collector. Let's see here. So can we draw it in a way that it would look like a pi? Yeah. So, and this resistance here, so basically I'm reconfiguring as if we're seeing Zn this way. So this is Zn, right? And so can we reconfigure it so it will look like pi? And the answer is yes. You could do something like this. And then the current looks this way. And then the emitter is down here. So this is the equivalent model. And this is the base. This is the collector. This is still IC. Okay? But this resistance here, Zn, is beta RE prime. Right here. So you could use this model right here, which is the pi model, or you could use the T model,